Okay, let's get started. Welcome to our session on Couchbase Analytics. Maybe you've seen a little bit of it during today's keynote presentation. Now I want to give a little bit slightly deeper look at it, not too deep. So the agenda is the following. So first, a few words on why we would want to have Couchbase Analytics. What are the thoughts about this? Did we think when we started working on this? Then a high-level overview of what it is. So what are actually the salient features of it? Then I will introduce you. We're using a few examples basically on how to use it. How do you talk to it? Have a little bit of information on the inside. So what drives it underneath? And then I will talk a little bit about the developer preview 4, which is the preview that is available since today. So if you went to the website yesterday, it wasn't there, but today you should be able to get it. All right. So why Couchbase Analytics? So we have talked about the fact that Couchbase builds an engagement database. And so if you think about an engagement database, you would like to obviously support the engagement with the customer, but you would also like to analyze the experience and the result of that engagement and bring those results back to the customer. And so that kind of argues for the fact that since you want to have this cycle or this loop in there, that you really want to support OLTP and OLAP processing in the single platform. So the transactional processing and the analytical processing should be done in the same platform. And we're doing that by eliminating the need for a separate OLAP system. And the first thing, as you might have heard earlier today before, is that we really would like to eliminate ETL. ETL has a number of disadvantages for us, right? First is it increases the latency. So basically by eliminating ETL, we can reduce the latency of the loops that we have between the transactions and the analyses. We reduce the complexity because, frankly, managing ETL and ETL workflow is quite tedious. And it enables you to get more intelligent applications as the result of the analysis will be available in the application again in a short time. And the other thing, of course, that we want to do is we would also like to enable data exploration and ad hoc analytics, right? Sometimes you have your data, you have the transactional data. You want to find out what you actually have. You don't necessarily know all the details of what you found so far, and you want to be able to just ask any question of your system and explore your data like that. All right. So now what is it? What are the kind of the features that make this up? So if you look at the wonderful picture at the bottom, you probably have seen this before, which is the Couchbase platform. Let me see if I can do this. Is this visible? So we have this unified programming interface, and underneath that we have different services, and we've probably talked about most of them today. So there's the query service, which is used using NoSQL. Then there is search, which is the FTS that you just talked about, that Marty just talked about. We have our mobile platform, including the sync gateway. And here in the corner, we have analytics, which is what we're just talking about, which is in developer preview. And all of this is based on the core database engine, which is where the Couchbase data nodes store that data. And so what we would like to do, basically the main features that we want to add here is, okay, so I already talked about this. One of the main features is, yes, we want to be able to allow you to run ad hoc queries, ask anything of the system, and asking anything includes the fact that, of course, the query language is powerful enough to allow you to express all of these questions. And it is also that you don't need to prepare the system to ask those queries. So basically, you can run those queries even if you did not set up an index before. It is able to manage all the data that you have, and you don't need to have special preparations and set up the system in a special way so that to allow you to ask those questions. The second goal is, or the second feature is the workload isolation. So one of the things that you see if you have Couchbase customers usually have high transactional workloads, and so the systems are well sized to support those transactional workloads. And if you want to run an analytical query, that's a pretty expensive undertaking and requires a lot of resources and CPU. And so you don't want to run that on the same nodes because it would basically slow down your transactional workload, which is the thing you want to avoid. So we want to have a workload isolated way to use resources of a different node in the cluster to answer the analytical queries and not the ones that we have on the data nodes. Of course, if basically as we want to separate these two things, we also want to be able to scale them independently. Your workload might have lots of transactions, little analytics, not so many transactions, a lot of analytics, so we need to allow for independent scaling. All of that we want to do by having a common programming and data model. So that's one of the big things. It's a platform, so if you know how to deal with one of the services, you should know how to deal with the other ones. So basically the APIs and the query language, that should all be well aligned. And so we would like to have this common model between the services, especially between the services that allow you to run queries. The next goal, of course, is a unified management. As you said, it's part of the platform, so the service should better be managed the same way that the rest of the platform is. And last but definitely not least, we want to have really fast data synchronization. As we said, one of the goals is that we want to analyze the engagement with our customers and bring knowledge about that back to the system. And so what we're doing is we're having really fast memory-to-memory data synchronization between the transactional system and the analytics. All right. So let's look a little bit about at how to use it. And so how to use it is, we'll talk about the query language right now, and I hope that many of those things won't be a surprise for you. That's the goal. The goal is to make it easy and have it not be a big surprise for you. So I hope I will reach that goal. So let's start with the data that we're going to work with, which is the beer sample. If you're with Couchbase or have worked with Couchbase, that has probably come across. So we have two kinds of documents in our bucket, which is one is beers and the other ones are breweries. And the beers here on the left side, you have a name, you have the alcohol by volume, a few other things. You have a type, which is the type that specifies that it's a beer that you see here, right? And a relationship to a brewery. And so on the other side, you have a brewery, and that has a name, a city, a state, and also a type down there. I can't even see my right pointer here, there. So basically, oops, sorry. So basically, you have those documents in the bucket, and you distinguish between beers and breweries by this type field. So let's look at a simple query on these documents. So we basically, what we have based on that bucket, we have two data sets here, a breweries data set and a beers data set. And what we do is very simple. We want to get 3 beers with the breweries, and what we do, we take the beers and the breweries, we join them on the ID, then we order them by name and by the brewery name and the beer name, and we limit this by 3 because it needs to fit on the slide. And this is kind of what you would probably expect. That looks like just regular SQL, right? That there's nothing surprising in here. The data is flat, the result is flat, and the join looks like a regular SQL join. So hopefully no surprises here. All right, let's look at the next query. So here we want to get 3 beer names used by different breweries. So what this is, basically what I do is I do a self-join between beers. So I have used the beers data set twice here. Then I join on the fact that the beer names are the same, but the brewery IDs are not. And then I get the beer name and one brewery and the other brewery. And again, I order this and limit it by 3 to fit it on the slides. And you'll see, that is, you have here 3 beers that are all called Scottish Ale. Obviously that is a very common name for beers that is used by many breweries. One thing that you will notice here, so the last join that we had was between beers and brewery, and we had a key, and we had a nice join that joined on the key, and that's all nice. In this case, we join on something that is not a key. And that is a difference between the query and the analytics service. The query service won't allow you to do that for a good reason, because the query service really optimizes for quick, short queries and that use index access when you actually find something else. While on the analytics service, we are willing to go the extra mile and to scan all the data so that you can answer these kinds of queries. And you have it in a workload isolated way so that it doesn't cost you in terms of your transactional performance that you can support on Excel. All right. So yet another one. This is a little bit more interesting. This is something that is not easily possible in standard SQL. So we get 2 breweries and a list of their beers. So basically what's happening now is that the result is not flat anymore. The result now basically is nested. It has a nested field, namely we select the name of a brewery, and then we have this subquery here, which is a subquery which selects different beers for the brewery, and which will be a nested object. This will become an array, and so you see here in the result, you have the beers with these two beers in there, the beers array with 2 beers, and the brewery. And that is a departure, right? Because in SQL, you have first normal form, so everything is atomic, so that's not the case here. And this basically shows you that the query language is really fully composable, right? It basically supports nested data at the bottom and nested data coming out at the top to support your application development. Because, I mean, one of the reasons why we often have nested data is because your application data is nested, and you want to have that and keep things together that way. All right. Okay, so now the system is called analytics, and so when you do analytics, you probably want to aggregate something. So this is a very simple aggregation query that, again, looks very much like SQL, or exactly like SQL. It gets all the breweries that produce more than 37 beers, and again, 37 is carefully chosen to make sure that on this data set we have 3 tuples as a result, or 3 objects. And it looks just exactly like a SQL query. You select the brewery ID, you select the count from beers, you group it, you have the having clause to limit the size, and then you order to get a nice result. Finally, putting it all together, a query that explores the beer characteristics by city. So what I'm trying to get here is I want to get the number of beers that you have in a city, in basically getting the city from the brewery, and you take the average of the beer strength to kind of determine how strong kinds of beers people like in the city, and you take the strongest ones. So basically what we're doing is we're taking the beers to the breweries, we're joining them again on the key, we're grouping them by city. We only take cities that have more than 1 beer, and then we just order by beer strength, which is defined up here to be the average of the alcohol by volume for the beers that are in the list. Okay, so this is kind of just an overview of the query language. I hope it gave you an impression. I hope all of these things were easily understandable and convince you that this is really easy to use, especially if you have seen SQL before in your life. All right, now the question is, okay, so we had these wonderful data sets and we ran queries on them, but so how did we get there, right? We said we wanted to get rid of ETL, and we mostly did. Basically, this is all the ETL you're going to see. So the DDL to set us up to basically run those analytical queries is the following. So the first thing we do is we have this create bucket statement that basically tells the analytics service, look, there's a bucket like this. It has this name. Please be able to use this. And then it will create 2 shadow data sets on this bucket. So basically, the bucket has the name beer sample, and so we're creating these shadow data set beers on beer sample with a filter, where basically we filter all the documents in the beer sample, and where the type is beer, it goes into the beers data set, and for breweries, the same. And then what we do is we connect the bucket beer sample. And so what's happening in that case is, so we create these 2 data sets, we connect the bucket. Now what's happening is that all of the data that is available in the data nodes will be made available for analytics. It will basically use the same replication protocol that we use for high availability in Couchbase, DCP, to get the data to the analytics service. And now you have it on another node that allows you to run it in a workload isolated way, your queries on that. And so now basically what you can do is you can run a query. So in that case, we select the 12 strongest beers, right? And then so we get a result. And so you got those 12 strongest beers in a nice cooler. Unfortunately, just as a picture, I'm sorry about that. It's 5 p.m. nearly, so you might want to have the original, but it's only a picture. And then you can tear it back down again. So basically, this is kind of the inverse of the creation that we had. We disconnect again. Now we're not connected anymore to our data nodes. Then we drop the data sets. We can drop the buckets, and everything is as it was before. One more thing that you can do, so this kind of assumes that this bucket is in the same Couchbase cluster as the analytics service. But you can also connect to another Couchbase cluster. So there's a way, and it's to some extent it's mainly a feature for the developer preview, where basically you can tell the system when creating a bucket that this bucket actually does not live on this cluster, but rather it lives on these nodes, which is basically tells the Couchbase client where to find the nodes. And then you can do the same rest of the DDL, and you can provide a password and a timeout here in the DDL to do that. This is kind of a testing feature. Passing the password here is maybe not the most high security solution, but if you want to try it out on your cluster and you don't necessarily want to bring all of your production data over to a new load, then you can do this. And the rest just works exactly the same. After this setup, everything works exactly the same as before. All right. Let's talk a little bit more about what's happening inside. So the first question I would quickly like to talk about is, okay, so we have these two services. We have a query service, we have an analytics service. They have a common programming model and data model. So the question is, okay, why do we have two? And we have two because basically they have very different target use cases, and they support different architectures. So the Couchbase query service is really optimized for operations, right? I mean, it's running on your operational data, and it's optimized for short queries, right? For many short queries that each touch a little bit of data. On the other hand, the analytics service is optimized for analysis. So basically, you have fewer queries, but those queries potentially touch a lot of data. And this difference in the use case, in the target use case that we have, also implies a difference in choosing the right architecture for the job. And so now anybody can kind of claim that this requires a different architecture and that that's actually different. And so to kind of underline that point, we did a little experiment. So we got yet another query here. The query is in a kind of a social media context. We have a messages data set and a users data set. And what we do is we join the messages with the users. Then we limit the results by providing a time window. Then we group that by user ID, order by count, and have the 10 chattiest ones. And up here, we get the user IDs and the count. And what we can do for this experiment is we have this window here with 2 timestamps. And by varying those timestamps, we can modify the size of that window and kind of understand what the operational characteristics of each engine are. And so we did this experiment. And so what we got were graphs like this. So what you see here is the blue one is analytics, and the red one is the query service with GSI. And you see here, basically, you have this is the scale. This is where the interval is 1 minute long. That's less than 10 objects that you have there. There's 1 hour. That's less than 500 objects. 1 day, less than 5,000 objects, and so on, up to 6 months, where it's a little bit less than 600,000 objects that you have in this window that's defined by these 2 timestamps. And so if you look at the left side here, you will see, okay, the analytics service takes quite a while the query service is pretty quick. And if you do that on the other side, the picture is quite different, right? So on the other side, if I see my pointers here, you have basically the analytics service is pretty fast, while the query service takes a lot of time. And the difference really is, it's a stark architectural difference. The query service is really optimized for those short queries, right? It runs the query on a single node. It does a quick compilation, right? That has a very low touch, that gets to the data node, or gets to the index, gets to the data node, and returns the result quickly. While on the other hand, the analytics service here on the left side, it is a partition parallel data processing engine, right? So basically what it does is when the request comes in, it does an optimization job, it actually spends time on the optimization, then it creates a parallel job that needs to be distributed on the cluster, it distributes on the cluster, then it starts the job, it waits for the results, it comes back. So there's a lot of overhead involved in that. And if you just basically want to have a very small result, this overhead, of course, is what determines the whole runtime. But if you have a big job that touches a lot of data, all of this overhead and the parallelization pays off, and then you can really benefit from that. All right. So what is the secret sauce? And I already mention? Yes. I think when we have questions, we need a microphone. Good. Okay, we'll do it there. Thank you. Sorry. So I already mentioned this, right? I mean, the secret sauce is not so secret because it has been used for a few decades right now. It's that we have massively parallel query processor that basically is able to distribute all the work that you do for those queries, all the scanning, all the reading from disk, all the computation across all the nodes, all the cores, and all the disks of all the nodes in the analytics cluster. And so basically, okay, this is a somewhat simplistic view of the world, but if the query basically takes 1 minute on one partition, then it takes 15 seconds on 15 partitions, and of course the scale can be much bigger. The other thing is that another property of this engine is that it has the comprehensive query language, as we just talked about, and that also the whole architecture is built in a way that it's able to deal with large intermediate results. So it does basically what you usually do. If the intermediate results are too big for a big join or a big sort, it starts spilling to disk so that you have a graceful degradation and that it doesn't fall over in case you actually have big intermediate results. All right, and so similarly, on the data side, is very similar. I mean, we already talked about the fact that we have these different services that provide, or these different nodes that provide workload isolation because the different services run on different nodes. And the same level of parallelism that we have when running those queries, we also have when getting the data from the data nodes to the analytics. Now, this is also running completely in parallel with the same degree of parallelism, basically using as much of the available network bandwidth to get the data over and to be able to analyze your data as soon as possible, as soon as it is in the data nodes. We're using, as I said, the same protocol that we use for replication for HA for also to get the data into the analytics nodes. All right. So let's talk a little bit about Developer Preview 4. So I'm not sure if you have followed our developer previews. So the last presentation we had was at Couchbase Connect in New York, and I think we've made a lot of headway since that. So when last time we had this discussion, many of these check marks that are now greenish or yellowish were still not in that shape because we still had a separate installer that was not really integrated into the Couchbase platform, and now with the current DP4, we're integrated into the platform. If you download this, you will basically get a Couchbase server with the analytics service, and it will have all the features that you want to have. So in terms of, the ad hoc queries, we were able to do that all the time. The workload isolation was trivial when we had a separate installer, but right now you basically have different nodes inside of the same cluster to achieve that. We're able to scale independently. We now are really close to having the complete common programming model and data model. And most importantly, we now have unified management. So before, our cluster sizes were static. So you would be able to just decide upfront what kind of the size of the cluster should have. And now it works in the way that you would expect it from a Couchbase cluster, that you can just add nodes and remove nodes and rebalance your data, and it all just works. And we do have the fast data synchronization, which works pretty well, but we still have some room for improvement in the quality of service, so that's why I didn't quite put a green mark in there, but rather a yellowish one. Okay, so just one example. So I'm really fast today, so sorry. So this is just one kind of screenshot, probably now thinking about I could have done a demo. About basically what this workbench looks like, what the analytics workbench looks like, and what you can do with it. So if you have seen the 5.0 query workbench, you will see a lot of similarity here. This has this query editor up here, which allows you to bring in your queries. Here you have the results. The results can be, as for query, represented in different formats. And here on the right side, what you have, there's a way to basically visualize to which buckets you're connected. So basically what you see here is there's a connection to the beer sample, and you have inside of that, you have the beer's data set. It is filtered by type, and the breweries, and it's filtered by brewery. And we also have a bucket in this cluster, which is the travel sample, which we didn't connect to, And so that shows up down here. All right. So now the important task is, please do me a favor, download it, try it. You can find it on the download page if you click on the Analytics tab down there. Then choose your operating system, download it, and please try it and give us some feedback of what you think. All right, thank you. I'm open for questions.
My question is query versus analytic. So do you use local index and global index differently? Like
yes. So basically the query uses a global index, right, to basically get to exactly the right point of data. And analytics uses local indices. So basically the indices are co-located with the data.
Yes.
And so basically when you want to access it, you can do that in parallel, all the nodes, and basically do your index-based access or filtering there.
Okay, cool.
No more queries. Oh, yes, please.
I have one question. Do we have some sort of near real-time analytics too, or all of the queries will take a long time? So for example, if I want to know in the past 10 minutes what has been the behavior of the system, or if there's any anomaly in the data, for example, if like the usage has increased dramatically, something like that. Can we use this system or not?
So there is, right now, in the current DP, there's no specific support for that. There is some thought about how to achieve that, or how to basically be more efficient in getting the latest information rather than the whole information. But right now, the queries would scan the whole data.
And basically. Okay, thank you.
Yes, please, Mike?
I was just saying, you could, indexing, right, is
yes.
an option.
Indexing is an option, but that is not specific to kind of, you could use it basically by indexing the timestamp, but it's not a specific. No, there is an index. Basically, there are, as we just said, there are local indexes in analytics, so you can use those to do that.
Is there any indication as to how much time the query is going to take with all the computations, costing, and other things that are computed, like a ETA? Whether it's going to take 10 minutes or it's going to take 1 hour, do I go for lunch and come back?
There is right now, no, there's nothing like that right now. So there's no estimation right now of how long this query will actually execute.
I noticed in the UI the little tabs on the top that allow you to display the results in the different forms. In the current query view, there's the visual execution plan as well as plan text. Is the visual execution plan coming for analytics? Because I didn't see that button there. And then is the plan comparable, the plan text comparable to the query format?
So right now, the plan that you can get for analytics is not visual. It's text in DP4. And and the format is quite different because of the difference in the engines. And you just step away from this? Yes, okay. So there is a plan, but it does not look like the one in the query engine at this point in time. And yeah, sorry. So no question. Is that a sign of too much clarity or lack of clarity? Sorry? Query result. Yes, well, yeah, that's, it's 5 p.m., so it would be about time for that. So, yes, please. Wait for the microphone, please.
Since it's an analytical query, do you support like a query rewrite? For example, if you first build some like materialized view, like build your analytics, later when they really run from applications, they can do some query write originally they use the like a normal database, but later they use an analytics database that work? Like a query rewrite, I'm not sure if you're familiar.
Yeah, no. I mean,
yeah.
there is a query optimizer that uses rewriting basically to rewrite the queries, and one of the things it does, it chooses indexes, right, to use or not, right. That's one of the things it does. We don't have materialized views or anything like this at this point in time, so it wouldn't support those.
Oh, okay. Is that a window function support?
No, not yet, but it's definitely on the roadmap.
Okay, thanks.
Yes, please.
So is there any difference between using analytics from Couchbase versus using the Spark connector to run, for example, Spark SQL on the same data set?
I mean, there are several differences. I mean, the first of all is, okay, you actually need to have the connector and you need to manage all the things. But the other thing is also that analytics runs on this nested data, right? I mean, the query language supports nested data at the bottom, at the top, and Spark SQL is just flat. So basically, you need to have transformations and everything. So we're really adamant on basically really supporting the flexible data in all services of the system, in all services of the platform, right? I mean, it's really a platform for flexible nested data, and that kind of shows, I think, in all the services that you're looking at.
Okay, thank you.
All right. Thank you very much.